Hello everyone, today I just want to show you how I am going to be analyzing my stuff. So this is an experiment that I had and these are my cells. This is a three-dimensional assay, so my cells are in a matrix in a little circle, and this is 2x magnification and they are Weka segmented. So if you watch some of my other videos, if you don't know what Weka is, it's a machine learning plugin that segments your stuff based on pixel intensity. So here I just took the circle region of interest so that it doesn't quantify anything on the outside. All I care about is this area. So I optimized my code for this plugin here. So this line right here, run properties, is going to, I have to change the channel. There's only one right now. Normally you can tell down here if it's divided into 2 or 3. That's 2 or 3 different colors, 2 or 3 different channels. But right now this is just one color. So that's just the one channel. And then I'm doing 1.7. That's my pixel to aspect ratio. So how many microns per pixel? For this microscope at 2x magnification, it's 1.7. Then I'm going to duplicate my image. So I'm adding the scale. I'm scaling it so that I can quantify anything that I get out of it. Then I'm duplicating the image. Then I'm making it binary. So you need to make it binary in order to be able to quantify. So then I'm running this plugin function that's called analyze particles, and you get to choose how small you want your particle to be. So for me, I'm doing mammalian cells, and they typically range from 10 to 100 microns in diameter. So when I translated that to area, it was about 80 microns squared to infinity. And I left it to infinity because sometimes cells get together. So you'll have like little clumps of cells. And when that happens, you don't know how big they're going to get. And so we don't want to exclude any cell clumps. So I just leave it to infinity. But anything smaller than 80 microns squared is probably not a cell. It's probably just like a particle or background noise or something like that. So let's go ahead and Control-Shift-R to run just that portion. Okay, and then here we go. We've got our little, we're gonna zoom in, so Control plus 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 plus, and you can actually see all the circles. Let's go in one more. So you can see every circle, so that's a cell, and it's numbered, all of them, and this is like a cell clump. You can see that this is like 2 or 3 cells together, and then you can see that this is like in white, this little particle. So that did not get quantified, which is great because it's smaller than 80 microns, so it's not a cell. And so Control minus, that's beautiful. It looks like I got everything that I wanted. Now let's look at our stuff. So this is our summary table. The name of our slice is what it's called, the name of this image. If this was like a Z-stack, or if there was like multiple colors, it would have like 1, 2, or 3. However many, it would have them down here by slice. So basically it's counting 2,101, I guess we could say cells or cell clusters. This is the total area. The average size per cluster is 682 microns squared. Percent area, so this takes up about 10% of the field of view. So the field of view is like the entire square. The perimeter, circularity, so the cells are about 70% circular on average. Solidity, and then a few other things that we don't really need, I don't think. I'm just looking for area and count. So then over here, our results table. This is where every single measurement is basically all 2,000 of them. And so you have like your individual areas here. And so yeah, I'm gonna go ahead and get rid of the, no, I'll save the summary as well. So I'm going to save everything. Remember to save any of these tables as CSV documents.csv, or else it'll save it like as an image or as a JPEG, and then you won't be able to open it and use the information. And then these, you can save them as TIFFs or as JPEGs. So I'm going to go ahead and do that now. Let's see, file, save as TIFF. I'll save it as a TIFF and as a JPEG. So okay, now I'm going to save the results, so save as, and I'm just going to save it with the same name, but instead of summary, I'm going to label it results. And then you can see that this is an Excel file, so it's saved properly. I always like to open it up and double check, so yeah, that looks good. Make that small, and then we want to make sure that this actually saved as a JPEG, and that's when you can actually see your little numbers and everything. If you just save it as a TIFF, then you're only going to see this. You can see that there's no numbers, there's no segmentation, there's nothing. So that's it. These are the 4 documents that I want to save for each one of these. And then once I'm done with all my images, I can go ahead and do my statistical analysis. Okay, so I'm going to do a complete one with you. So this is the same cells but with a drug, and you can already see like a huge difference. You can see a lot more clumping. The cells are actually getting together over here, and it's also a lot more dense. There's like so many more cells here. So then we're just going to do the exact same thing. We'll run the same code, Control-Shift-R, and here we go. Wow, so we have 2,900. There's a lot. There's just a lot going on here. So first thing I save is this guy. We'll go to File, Save As, and we'll say as a TIFF. Okay, and then it already has its name, so we don't have to type anything in. But I like to remove that. I'll just leave it as N2, save, and then I click on it again, and I'm gonna go to File, Save As, JPEG, so we can keep our map. But here we don't want to give it a crazy name, we just underscore, save. Now we'll go to our summary, so File, Save As, and then we just click on there, and then we type summary, save, get rid of that, and then File, Save As, click there, and we just type results. And that's it. We just do that for every single one of these. If you're good at coding and good at Fiji, then you can automate the folder function for this. But I was having trouble getting a couple of things to save, so I haven't automated that yet. Okay, so now that I'm ready, I'm going to go ahead and do count, total area, and average size. So I'm just going to their summaries, and I'm making that red and bold, and then I'll just go ahead and copy all of this, Control copy. So I'm probably going to be making 3 graphs with this information, and so there we go. So I have my tip stock and tip stock with the drug, and then the other cell type, and then that cell type with the drug. So I'm taking from the summary, the average over here was the count for phalanx with sunitinib N1, so that's this one right here. So the count was, whoops, Control Z. Okay, so the count is this one, Control copy, and then that goes here. Okay, so 3302 is the count, and then for total area, that was this number here, Control copy, total area, and that's phalanx with sunitinib N1. And then average size, Control copy, N1. Okay, so I'm done with this one. I can go ahead and delete all of this. Okay, so now we have our phalanx with sunitinib N2, so we're going to go ahead and grab our count, Control copy. So yeah, phalanx with sunitinib N2. the count is this, and then our total area this, and then our average size. Control copy. And there we go. All right. Okay, so then it looks like we're done with all of our stuff here. So we have all of our numbers. This one I miss. Oh, this one I'm missing right here. We don't have a picture for that day, for that sample. I'm not sure why, but we're just gonna go on without. So we're gonna go to equals average, double click here, select your columns like that, enter, and then we want the average for all of those, and then this one we have to do it manually because I think otherwise it would take this one as a 0, and we don't want that. It'll throw off the actual average. Okay, so those are the averages, and then here we're gonna do standard deviation. So we're gonna say equals STD standard deviation. So it's gonna go here. Oh, just the first 3. Okay, and then we'll take it down. Okay, and then here we're gonna say equals D standard deviation, this one, the normal one. Okay. Okay. And then we're going to do the same for all these right here. Okay, I brought you in a little bit closer. Now we're going to go ahead and start making our graphs. So what I'm going to do is I'm going to take, copy, I'll put it right here. This, and then we'll just take our average. Actually, I think we have to take our average and our standard deviation. Put it here, and then click here, press. Am I recording? Okay. Paste values. Boom. Okay. Make sure the values are perfect. Yeah. Okay. So now we can go ahead and you highlight this. Just the average. And then we go to, not that one, this one. Charts. I like clustered columns, so I'll put this guy up here. And then I'll write down count. I'll make the titles later, but for now this is fine. So what I like are access titles. Data labels, I like them, but my PI doesn't like them, not really. We're gonna have error bars, no grid lines, and then we need a legend. Okay, so basically access titles is just gonna be a sample. Yeah, sample, because we have, and then count is gonna be average cell number, average cell count. Yeah, so average cell count. Okay, so then we have our tip stock with sunitinib, phalanx, and phalanx with sunitinib. Okay. Yeah, so this is gonna say cell count, cell number after 5 days, something like that. It's 5 days later. I'll go ahead and come up with the titles later, but basically this is all we want to do. We want to have error bars, but for these they're not normal, so we right click on them. There we go, right click, format error bars. We go to custom, specify value, and then we grab our little, I don't know why it always appears way over there, but basically we want to highlight this, and then you go here and you highlight the same thing. So it's just in the positive and negative space, and now we actually have accurate error bars. So you can see that there's no negative error bars anymore, and like they actually make sense based on our data. So then here you can see that our tip stock cells, there's like 0 cells after 5 days, and then for the cells that had the drug, there's actually some cells left over, about 500 on average. And then for the phalanx cells with no drug, there was like this many, and then for the phalanx cells with the drug, there's actually more. So the last thing we have to do is determine if this is statistically significant. So what we have to do is we have to perform an F test, and I'm still kind of learning how to do that, so I'm not going to do that in this video, and then we have to do our t-test. So I'm pretty sure that the f-test will tell you if your data is variable. So does it have high variability or not? And there's like a simple way to determine that, and that's like you get your variance. You get your highest variance and divide it by your low variance, and then if the answer is less than 4, then that means that your data is not it's not highly variable. It's basically the same. It has the same variability, and you would do a type 2 t-test. And most of our stuff that we're working on is type 2 t-tests. So that's what we're going to go with today, just for today's video. And then later I'll make another video for the f-test, but I want to go into detail about how to do that with the alpha values and all that. But yeah, that's another video. So here it's going to be type 2 t-test is what we're going to be doing. Okay, so then the first thing you do is you go equals, and we're going to have a few. Actually, let's see if we can enter. How do we make more? No. Tab, no, okay. Insert. Okay, so yeah, we'll insert a few more because I want to do a few t-tests. Okay, so here we're going to delete that. Okay, so basically the first t-test is going to be between the tip stock cells and the tip stock cells with sunitinib. So remember, no drug, but it's the same cell type. So we're going to go equals t-test, double click on that, and I like to double click it here because I like this window. It just makes it easier for me. And so then array number 1 is just like N1, N2, and N3 for the tip cells, and then array number 2 is just N1, N2, and N3 for the tip cells with the drug. We're going to do a two-tail t-test because it can go left or right, and then the type of t-test is going to be type 2 because the variance is about the same. So then we're going to press OK. Okay, so it's 0.12. So if it has to be less than 0.05 to be significant. So here it's not significant. So then up here I'm going to write down what this is for. So it's just going to be tip versus tip. And then here we're going to do tip. We're going to do, actually we can do phalanx versus phalanx, and then over here we can do tip in red. Tip versus phalanx, and oh yeah, tip versus phalanx, and then we'll do a minus sign so these guys won't have what do you call it, the drug, and then we'll just paste it. And then this one will be a plus because this one will have the drug. Okay, so then we're just going to do the same. Copy. Okay, so then here we're going to do equals t-test Okay, and then we're going to do phalanx and phalanx, so it's going to be these three, comma. So if you don't want to use the that table, then it tells you what to do here. Array 1, array 2. So my array 2 would be this one, comma, and then tails, it would say 2 tails, and then comma, and then type of t-test is 2. Okay. Enter. So 0.04. Hey, that's less than 0.05. So the phalanx actually are quite different. Statistically significantly different. Okay. So I guess there's more cells with the drug. So they're what do you call it? They're dividing more. Okay. So then we're going to go equals t-test. And this one's the tip versus phalanx with no drug. So tip, no drug, and then comma, and then phalanx, no drug, and then it's going to be a 2-tailed, comma, type 2, parenthesis, enter. Okay. Times 10 to the negative 5th. Okay, that's really significant. That's great. So then we're going to do tip versus phalanx. Oh, why does this have... Okay. This is supposed to have a plus. Okay. So equals... So that's tip with the drug, comma, and then phalanx with the drug, comma, and then 2-tailed, type 2. Enter. Okay. So that's also significant. That's great. Okay, so then this once we determine significance, we take this to our PowerPoint, so we can just go, I think I'll put it here for now. So paste. So there we go, we have this guy, and then when we wanna, okay, that guy's not supposed to be here. It shouldn't be like overlaying, you can like move it. There we go, that's fine. Okay, so then insert, we would do a shape of a line, and then you press shift, and that'll make sure that the line is straight. And so here we're just gonna go to make the line black, and then shape outline, weight, and I always like to make the line like thicker, maybe 2 1/4. Yeah, 2 1/4 is good. And then insert text box. Okay, in this text box I just make the stars, so it'll be like 1, 2, or 3 stars. If something is significant, you just put it like right there, and like that's how you make your graphs. Yeah. Okay, so we're gonna go ahead and do that. We're gonna make our graphs for like all of these things, so we'll be able to get 3 graphs from this data.